In the 9th lecture of probability theory, we considered the first specific case of discrete random variable, the binomial random variable. In order to properly define it, we first defined a Bernoulli trial and the associated Bernoulli random variable, and then computed its expectation and variance. We could then define the binomial random variable as the sum of n Bernoulli random variables. We computed the probability mass function of the binomial random variable and proved that this is a proper probability measure in the sense that it satisfies Kolmogorov's axiom 1 and axiom 2. After considering some examples, we computed the expectation and variance of the binomial random variable. By making use of the fact that it is defined as the sum of n independent Bernoulli trials.